Conics section that we are going to discuss is parabola. By definition, parabola is the locus of all points in the plane whose distances from a fixed point, which is called the focus, and a fixed line are the same. And this fixed point is again called the focus, and the fixed line is called the vertex. So this one, from the center or from the vertex to this point where the directrix is, as well as from this vertex to this fixed point, which is called the focus, these are equal. We have here the different parts of the parabola. So we have here the curve. It's either opening upward, downward, to the right, or to the left. And we have here the focus, the fixed point. This is the vertex where the axis of symmetry passes through. And this one is the directrix, wherein the distance from this vertex to this directrix is also equal from this point to this focus. Then we have here the different positions of the parabola, which will also be our guide. So in the book and in your kit, I also use A there, so don't be confused if you see. So P or A are just the same, only in some contexts or in some books or some illustrations, the P there is changed to A, but still it represents the same. So we have here, this portion here is when the vertices or the vertex is at the origin. So here is the given figure. It opens to the right, then this is the given y squared is equals to 4ax. If it opens to the left, y squared is equals to negative 4ax. Okay, or 4 negative 4ax. Here goes up, so it's x squared is equals to 4ay, and here it goes downwards, it's x squared is equals to negative 4ay or negative 4py. It's just the same. And then this given here is when the vertex is at hk. You will already see this kind of format for the equation, the standard form. This one, that's P. P stands for A also. It's very important to know the different guides, the formula for each corresponding points. Here, the endpoints of the latus rectum, and where we have this focus and then the vertex. There is also a specific length or distance of the latus rectum. This portion here, and also here, this is the latus rectum if it's downward. Now we have here important points we have to take note if we are going to solve for vertices or for parabola with vertices 0, 0 and for hk. We have this one. These are the equations. The length of the focus with the A, P or A are just the same. The width is 4P or 4A. Here are sample problems. The first one is we are going to find an equation of the parabola with the given conditions. First is the focus is at 0, 2 and the directrix is y equals negative 2. So that means we need to find the vertex, and since the directrix is y is negative 2 and then the focus is 0, 2, we can find here our given. Our A therefore is 2, and then using the formula x squared equals 4ay, since shown here that the vertex is at 0, 0, and then just move forward 2 units to get the focus and 2 units to get the directrix. So the parabola here is opening upward. Vertex is at the origin, and 0, 2 for the focus and y negative 2 for the directrix. So it's the axis of symmetry is vertical. Then we have to solve for our equation. X squared equals to 4 2y, wherein our 2 is the A. Then we have the exact answer, which is x squared equals 8y. And the second is the axis is horizontal, again in the form y equals k, since the focus is at the left of the vertex. So since the vertex is 6, -4, and the focus is at -2, -4, so that means it opens to the left and with horizontal axis for that. So for A is -2 minus 6 equals -8. And then this one, y minus k squared equals for A. Since the vertex is at hk, so you have that to substitute. Look at this one here, our equation here. In the given, we are going to illustrate our parabola here. The focus is at 0, 2, and then the directrix is y is -2 of the parabola, means it opens upward. Our focus, the origin is our vertex, so that means it goes up the parabola. And then the latus rectum is where it passes to the focus. So somewhere here is our latus rectum. This portion is our focus, our center, and this is our directrix, which is y equals -2. In the second problem, we have here this one. So if I'm going to have continue, let's have a higher value of that 6 here, and this one here is 4, so somewhere here is our vertex. The focus is to the left of the vertex, so the focus is -2, 4. That means from here up to here is 8, right? It's the distance. This is 8, so this is where our directrix. This is the axis of symmetry. We have parabola. We have another example. Sketch the parabola with the given equations showing its vertex, focus, directrix, and axis of symmetry as well as the latus rectum. X is -y squared over 2. For this, we are going to write it into this form. We get -2x. That means our 4a is -2. So solving for a, it's -1/2. And then still we can see here the vertex is at 0, and the focus is -1/2 0, and the axis of symmetry is y equals 0, and the directrix is x is equals to 1/2. So we're going to solve for that. Our vertex is here, and then our focus is -1/2 0, so if this is 1, so this is -1/2. Our directrix is +1/2. Focus is -1/2. Our axis of symmetry is this one. Okay, and then the other problem, yes, for the latus rectum, so it's somewhere here, this -1/2. So if this is 1, and this is -1/2, so our latus rectum is here. This one, -1/2, 1, and then the other is -1/2, -1. So our latus rectum. Okay, passing to the focus. We have that. Then another is this one. Again, we are going to complete one of the things. So it's perfect square. And we have this. So for the given, so we have here this one, where our a is 1, because 4 times 1. Our vertex is at 2, 3. Our axis of symmetry is x equals to 2, and then the focus is this one. This is our focus, the vertex, the axis of symmetry, then our directrix, and then our latus rectum. If we are going to draw this one, the vertex is at 2, 3, so where is 2? And this is 2 here, and then 3 is in here, for example. So this is the vertex, and then the focus is at 2, 4, 2, 4, so somewhere here. So that means it opens upward. My directrix is y equals to 2, so that's somewhere here. So we'll have our directrix. So the directrix is here, passing through this point where it says y is equals to 2. Our focus here in vertex of the neutral line, it's opening upward, and then our latus rectum is this portion passing through the focus. We will at this version again. Properly closer my earliest victim is over here. So we have that as your graph, a rough sketch of our parabola for this one. And we have our this rectum focus of 0,4. That's over here. Since it's a rough sketch, so we're going to adjust this portion. And adjust this part. And then the other is 4,4. So these are the endpoints for the lattice rectum. And this one. That ends our discussion on parabola. So that will be all. Goodbye, and see more videos that I included in this file. Thank you and God bless.